afternoon, Jackie. Welcome back again at
Thanks.
the CRI workshops here in Paarl again, and it's good to check back in a year later. Last year we had a discussion about Alternaria, and we were tasked to do that again with you. So, yeah, welcome.
Yeah, thanks, Deval. Thanks.
Welcome. Yes,
Thank you.
and to catch up with you and to hear what I think a little brief explanation of what is Alternaria is always a good start, and what is CRI doing about Alternaria?
Okay, yeah, thanks. Alternaria is causes quite serious problems in citrus. It causes Alternaria Brown Spot, which we see on leaves, on twigs, on fruits, and when there's a very severe infestation of fruit, it can lead to fruit drop. The fruit can be very severely diseased, so much that you can't export. You might struggle to get onto any market, so that have to be juiced. So there's quite a huge economic component in terms of Alternaria.
So, excuse me, I'm going to ask the dumb question. Is it a bacteria? Is it a fungus? What?
Yeah. So Alternaria, the ABS is Alternaria Brown Spot, is caused by Alternaria alternata. This is a very common fungus. It is a pathogen on copious hosts, many hosts, probably over 200 different hosts. It's also able to survive on dead and dying plant material. So it's a saprophyte and a necrotroph,
Oh, wow.
which means that it is basically ubiquitous. Yeah.
Okay, that's interesting. Didn't know that.
Yeah.
Goodness.
So the discussion last year, we chatted quite a bit about the things like similar to what you've just said, and that was quite an interesting discussion. So, what is CRI working on at the moment in terms of Alternaria?
So good question. We realized that the industry doesn't screen for new cultivars before they're released onto the market. And in the literature, there are a number of different techniques that are used to screen for susceptibility to Alternaria, but we couldn't really find a consensus. One technique that is used worldwide that is repeatable and accurate. So what we're doing is we have looked in the literature and identified all the different techniques that are used to screen cultivars for their susceptibility to Alternaria, and we are now comparing them to one another. So as a start, we're using a susceptible and a tolerant variety, two varieties, so that we already know what the response should be, and we're screening all these different inoculation methods to look for one that's not only easy to perform but is repeatable and gives us accurate results. So that's on the phenotypic side. And then linked to that, we're looking at the genotypes of cultivars, and we want to just confirm that the genotype corresponds with the phenotype. In literature, it's been published that there's a specific mutation, it's a SNP08 in cultivars, and if you have, or in some cultivars, when that is present, homozygously, then you will get resistance to Alternaria. So we are screening for the presence of this mutation in different cultivars, and then we want to just correlate that when we find this mutation, that we will actually see that the cultivar is resistant to Alternaria. So this is what we're currently busy with. So the idea is that eventually we can roll this out and say we have a genetic marker, and we have an inoculation method that one can use to screen new cultivars.
That's very exciting.
Yeah, it's really exciting work.
And the fact is that you are working on something. Yes, you are still working on it, but you're working towards something which is going to help a massive disease for the industry.
I'm very excited because I think it will give us an avenue to hopefully control this disease in future. At least it will prevent us from establishing new cultivars, spending millions of rands, establishing a cultivar that we then later realize is susceptible. So, this is an exciting project.
Has that happened previously? That cultivars have been...
Yeah.
Okay.
There have been some examples where cultivar has been rolled out and planted, only to realize that it's highly susceptible, and actually one needs to just stop work.
Yeah, because you don't just, it's not just the fact of losing a tree, you're losing 5 years of investment into that orchard to get it.
Yes.
To get it to bearing.
So the adage, prevention is better than cure, and you're working on that
100%.
prevention thing.
We are definitely.
So
Wonderful.
if you guys managed to find this? How would this be practically implemented in an ideal world, or what would you like to see? But is it something that a farmer would be able to do? Would CRI still be involved with that process?
So I think it's not for the farmers. It actually goes a step back to that. So it's the companies that are developing new cultivars.
Okay.
So before they even bring them to CRI to be planted out in trials, they will be able to test their cultivars, to screen them on a genetic basis and phenotypic response to the disease, and then perhaps just cull some of them before they take it any further. So before they even spend any more money, they should know already what the susceptibility status is of the new cultivar.
Oh, wow.
So basically, you're going to be coming up with, you hope to be coming up with a tool which is going to eliminate, it's going to prevent that from happening, and it can be used in South Africa and potentially elsewhere in the world as well.
Yeah, definitely. That's exactly
Wow.
right. Yeah,
That
very
is super exciting.
It is. It is an exciting project.
How does it feel to work on things like that?
It's awesome.
From a scientist perspective.
It's always great to work on something where you know you will really have an answer, a tool, as you said, at the end of the day that could actually have a very significant impact. So, yeah, where you can see the application of what you're doing. It's exciting.
That is super exciting, and the best of luck with that. And let's keep talking about that, because it sounds to me like this could be something really big.
It's an exciting project for sure.
So I have another topic on this to ask you about, and that is, you know, from what we hear, there's a lot of talk in the crop protection environment about people, particularly when they're referring to an insect or a bug type of thing that needs to be controlled, to not spray preventatively, to wait and see if infestations occur before you spray. But we're dealing with something completely different here. And it is an exception to that, and a very important exception to that. You were saying you have to spray preventatively.
Yeah.
Can you tell us a bit more about that?
Yeah, so you're right. It does differ for pests and pathogens. And we want to protect our trees, fruit from infection. So we actually don't want to act curatively. We do have some fungicides that have a little bit of a kickback action, but it's not ideal and it's not always 100%. So it's better to spray preventatively. However, of course, as we know, we don't want to put on too many fungicides. But there is also a tool that we have in CRI, which is a project that's basically also wrapping up now, where it is a risk prediction model. So it's built into Fight Risk, which I'm sure everybody is very familiar with. Fight Risk was initially established for CBS. But in the Fight Risk, or on the Fight Risk platform, we also have an Alternaria infection risk model. It's based on a model that was developed in the early 2000s in Florida called Alternaria, which gives one an indication of the likely risk of infection. So this assists us in knowing when we're likely to have an infection, and therefore growers can spray their applications, their fungicide applications at the right time, and not waste fungicide applications.
So that's if the conditions are probably going to be good, that infections will happen.
Exactly. So if infections are favorable for, if conditions are favorable for infection to occur, it will give you, it's almost like a robot system, a green, orange, red indication of green is fine, no infection, orange likely, and red most definitely going to have an infection. And this is based on empirical models that have given us details on temperature and relative humidity and leaf wetness required for infection by Alternaria.
That's another very exciting thing.
That is an exciting project.
Wow.
Yeah.
So how will that work in practice? Okay, I'm a farmer. I am somewhere in the Lowveld. I farm with fruit that could potentially have this problem. How is this going to help me? How does it work? How's it going to roll out?
Okay, so when one opens the Fight Risk platform, you would then select the Alternaria model. And this, like I say, is based on the environmental conditions. So, for example, let's say you are in the Lowveld and it is the beginning of the new season, so August, September, and it's hot. So temperature-wise, conditions would be favorable for infection. However, it's very dry. So it's unlikely that Alternaria would infect, even though it's present in the orchard. So then you would probably get a green. So it would say no chance of infection. So instead of just spraying on a calendar spray saying, okay, I have new flash, I'm going to spray, rather look at the model and get an indication of the conditions. So see whether it's actually necessary to spray. If it's not necessary to spray, then check it daily, but only spray when infection or before an infection period. So this might save one or a few fungicide sprays in a season, which of course translates directly into an economic impact. And also the fewer sprays we can apply, the better in terms of MRLs, and of course the better in terms of resistance management as well.
And environmental.
Yes, impact.
And that fits in with the IPM.
It does,
with the IPM advice that you need to monitor and treat what is needed.
Okay.
Yes, exactly. So in terms of a fungal disease, one can't really, it's not so easy to just determine a threshold because you can't see the fungus sitting on the leaf. So this is why we work on infection risk models rather than actual presence of it, because by the time you see a symptom, it's too
a problem.
late. Yeah.
It's a big problem then.
But so these are both tools. The first one you discussed, and this one is providing growers with. This one is a tool that they're going to have reasonably soon. Do I understand it correctly?
The Alternaria is already actually available, yes, so they can use it.
So they can make an informed decision. They can look at that, look at the situation, and actually make an informed decision.
Correct.
As opposed to just saying, it's Tuesday, the 20 whatever of the month, and we must spray preventatively. They can look and make a decision.
Yes.
That's 100%. Very cool.
A question on that is, so the tool is there, but are the growers using it?
I think some growers are. I don't know how many are, but definitely I know of some growers that are using it. Look, we know that the tool for CBS is used very widely.
Yes.
So I'm sure that once we make growers more aware of the Alternaria model, more growers will use it.
Okay. And is the conditions between CBS and Alternaria vastly different, or can you do them at the same time?
The conditions for infection are fairly similar, but Alternaria starts to infect a lot earlier.
Okay.
So we generally start Alternaria sprays earlier than CBS sprays.
Okay, so that's if the guy waits and he says, "No, I'll treat it with my CBS," it's too late.
Too late.
Okay. So they'll need to keep a finger on it from just before the new season starts.
Exactly. Correct.
Oh, interesting.
So if you've got a kind of wrap-up comment for growers, from what I'm hearing from you, there's good news because there's some stuff coming that you're working on. And there's good news because there's some stuff available right now, which they might not know about.
Yeah. Definitely. I know that Alternaria is a very challenging disease. If one has a susceptible cultivar, the pathogen which is present ubiquitously, and favorable environmental conditions, it is very difficult to control. We know that. But we are working on tools, and maybe in future we will only be planting cultivars that have resistance, and that would be quite an exciting change.
Fantastic.
Excellent. So, exciting things to look forward to down the road, and I definitely think we'll be chatting to you again.
Yes.
Thanks so much for joining us.
Thank you. It was
and
really great.
All the
Thank you,
best
guys.
with all the studies and everything.
Yes.
Yeah, thank you very much.
It sounds
Appreciate
exciting.
it.